Okay, let's continue. Graphs of functions, part 3. Let's find all the critical values of this function, which is f of x equals, x into 2 minus x to the power 3. And we need to find where the function f is increasing, decreasing, where we have saddle point, minimum, local maximum, etc. Same, we do the same thing. Either we can expand this function, but we don't need to. Domain of function f, since it's a polynomial function, then it is all set of real numbers, or from minus infinity to plus infinity. Same. Derivative. It's u times v. So it's u prime v, right? Minus v prime u. Minus u times the derivative of v prime. Derivative of v prime, it's u power m. It's 2 minus x to the power 3. So its derivative, it's a 3 times 2 minus x to the power 3 minus 1, which is 2 times the derivative of 2 minus x. Don't forget that, which is minus 1. So the answer is 2 minus x to the power 3 minus times minus 1 times minus x. It's plus 3x, right, into 2 minus x to the power 2. What is, we have a common here, common factor 2 minus x to the power 2 in both terms. What left inside is 2 minus x in the first term plus 3x in the second term, right? So it will be 2 minus x to the power 2 into 2 minus x plus 3x. So it is equal to 2 minus x to the power 2 into 2 minus 2 plus 2x, right? 3x minus x. Now, let's take f prime of x equals 0. Taking this equals 0 gives me either 2 minus x to the power 2 equals 0, which is 2 minus x equals 0, and that gives us where x equal 2, right? And or we have another factor, 2 plus 2x equals 0 gives us like 2x equal minus 1. This means x, 2x equals minus 2. This means x equals minus 1, right? Those two values makes the derivative equal 0. Let's do the table of variation. Table of variation, it's x goes from minus infinity to plus infinity because it is defined over all r. Here we have two values, minus 1 and 2, only the two critical values we got. First, we have 2 minus x to the power 2 as one of the factors, right? 2 plus 2x, the other factor, and f prime of x and f of x, right? 2 minus x squared equal 0 when x equals 2. That's what we got. And since it's a squaring value, that's, you have to pay attention for, it's all positive, squaring value. Positive or equal to 0 when x equal to 2. 2 plus 2x is 0 when x equal minus 1, same as the coefficient of x, to the right, opposite to the left. 0, 0 for derivative, minus plus when we multiply them. Decreasing the function f of x, we can say, I will not write them, but we can say from minus infinity to minus 1, the function f of x will be decreasing function. From minus 1 to 2, it will be increasing function. From 2 to plus infinity, it will be increasing function. Derivative, from minus infinity to 2, from minus infinity to minus 1, then from minus 1 to 2 changes its sign. That from negative to positive, so from decreasing function to increasing function, it makes a local minimum point. And From -1 to 2, it's positive. From 2 to plus infinity, it's positive. Do not change its sign. Then it is what? It is saddle point. And that's it. That's it for this one. Okay, let's start in the behavior of the function at infinity. What happens? Let's do this activity. We have f of x. We have f of x equals to minus x power 4 minus x power 4 minus 7x to the power 3 plus 12x squared and plus 8x plus 8. We need to know the behavior of this function when x approaches negative infinity and as x approaches positive infinity. Okay, in this case, we just take the dominant part, the dominant term of the function. If it is polynomial function, we take the dominant term, which is the term of highest exponent, which is the first term. So we just look at this term. Now, as first, what do we have in this term? First, we have the degree, n is equal to 4, so it's even. So whatever x is tends to negative infinity or positive infinity. In both cases, x power 4 will be positive, but the coefficient of x squared is negative. That makes the whole term negative as x tends to negative infinity or x approaches positive infinity. So that makes f of x is strictly negative value when x approaches negative infinity or x approaches positive infinity. So negative infinity raised to power 4, it will be positive, multiplied with negative 5, it will be negative value. Same for positive infinity, because we are multiplying in a coefficient negative 5, sorry, and the degree is even. And that's it for this one. Let's do it in another video. We are going to start rational functions. We will do it in another video.